Yes, ma. A very good afternoon to all. Today we'll be discussing with one more example. For one address instruction format, x equals to a. This is the expression. Let me write. Okay. So very good afternoon to all. Today we'll be discussing with one more instruction format with this given example, one address instruction format. So if we want to go for one address instruction format, we must know that we'll be using in one address instruction format called a single accumulator concept. Okay, so single accumulator concept will be using two main operations called a load and a store. A load means we are loading the contents from memory into an accumulator. Store means we'll be performing some operations and we'll be storing the result inside a from an accumulator to a memory. Is a storing back the result to a memory. Okay, so let me give one example. I want to perform a plus b. So if I want to perform a plus b, so here see an example. What does this indicates? Add b indicates what? Add b indicates that we are performing addition with the contents which are available in an accumulator. So in an accumulator we'll be having a contents. Okay, so here we'll be adding accumulator plus b. Means what? One of the operand will be present in an accumulator. This is the first operand which is available in an accumulator called a. So in an accumulator we'll be having a and b will be getting from the memory location. So in the same way, try to consider this example. Okay, so if we start with numerator, the above one, so what happens is the accumulator result has to be stored in a memory location, memory location, so that in an accumulator we can store we can load a denominator. But what is happening is the main concept is the first operand should be accumulator. The first operand should be an accumulator. So here what we are doing is, instead of starting the one address instruction format with a numerator, we'll be starting with the denominator, and this will be storing in some memory location. For let us consider, for sake of, I want to store inside a t. Then I want to perform this operation. So if I want to perform after this finally will be present in an accumulator. Okay, so that's the reason that I'm starting with the denominator first. Okay, so let me start with the denominator, so that this result can be stored in a memory location. Then we can start, and so that the numerator value will be present in an accumulator, so that whenever we'll be performing a division operation, you will be getting accumulator by the memory location. Okay, so let me start with a one address instruction format. So here first is load. Okay, so we need to load. The parenthesis will have a highest precedence, so I'm loading a g, which is nothing but load indicates we are loading the memory location g contents inside an accumulator. So it is m of g. And next is what? Next is we need to perform an add. So add h means what? Inside an accumulator along with an accumulator values. Why? Because one of the operand will be present in an accumulator, so which is g. So g plus m of h, h. So this is your add. Next you need to do mul. Okay, we have a multiplication, so we are doing mul with a f, so that the accumulator, in an accumulator we have g plus h, the accumulator up into we need to go for m memory location, m of f, m of f. Okay, so we completed. So once completed, we cannot go for the numerator, and we cannot load the content, load d. Why? Because this entire part is available in an accumulator, so we need to store it in one location so that the result will be stored. Okay, so you'll be going for store, where we need to store in a location t. Okay, so store t means in a memory location t we are storing the accumulator content, which is f into g plus h. Okay, so in a memory location, so in a memory location in a memory location t, which is in an address called 200, the contents of accumulator, what we have in a accumulator ma, f into g plus h, we are storing inside this one. So this will you will be having f into g plus h. Okay, now I stored the result. Next I want to go for load. Okay, so as parenthesis will have a highest precedence, we'll need to start with parenthesis, load d. So this one, load d. So load d means what? Inside an accumulator we are storing the m of d contents. Next we have an operation called add. So perform add e, so that accumulator contents will be added with the accumulator which is present, the accumulator data which is d plus e plus e. Okay, next we need to do mul c, means what? The accumulator, in the accumulator we have d plus e, and with that we need to perform an a multiplication with c. Okay, next add next add this one, add b add b. So add b accumulator. So inside an accumulator we have until here, we have until here, where is, okay, we have until here d plus e into c stored inside an accumulator. Okay, so now so that plus b. Okay, accumulator contents plus b. Finally we need to do what? Multiplication. So finally mul a means, again inside an accumulator we have this entire portion, which is b plus c into d plus e, with the memory location which is present in a. Again we are storing entire result in an accumulator. Okay, so accumulator equals to accumulator in multiplied with a memory location m of a. Okay, now what we have in an accumulator ma? We have in an accumulator presently, in an accumulator we what we have in an accumulator, we have an expression, this numerator one, this one, we have this one, which is a into b plus c by into d plus e. This one we have in a accumulator by the f. This is available in location t. Okay, this is available in m of t location. Okay, so for that next operation is division. So one operand is present in an accumulator, and the other operand is present in a memory location. So let me complete this. So next is what? div operation. So div, what we need to mention? It is located in memory location T, location in T. So we'll be storing accumulator will be having this the numerator value, which is a into b plus c d into d plus e, divided by the denominator value will be present in a memory location, which is present in m of t. Okay, which is present in m of t. Finally, the entire result is available in an accumulator, which is a into b plus c into d plus e divided by f into g plus h. Finally, this has to be stored in a memory location X. So what we need to do for storing the result from accumulator to memory location, we have to use a concept called a store and the location in X, so that the accumulator contents will be stored inside a memory location M of X. Okay. So this is a one address instruction format where we'll be using a single accumulator organization. And thank you, Ma.